Alright, number 80, cobalt 3 sulfate. Cobalt 3 is a 3 plus. Sulfate is the 4 oxygen, SO4 2 minus. We'll go from silicate, which is a 4,4, to phosphate, which is a 4,3, to sulfate, which is a 4,2. And so we're going to need 2 cobalts, will give us a total charge of +6, and 3 sulfates, which will give us a total charge of -6. So CO2, SO4 parentheses taken 3 times. Then we go to iron 3 iodide. Iodide's a 1 I minus, so iron 3 is Fe3 plus, and so we'll need 3 iodides, FeI3, and then copper and phosphate. Here we could figure out the charge on it either by writing out the ions here and then figuring out the charge. Phosphate is a 3 minus, PO4 3 minus. So we got 2 of those, and then we have how many coppers? We got 1, 2, 3 coppers. And so the total negative charge is -6, and therefore the total positive charge must be +6. You'll see here. And that means +6 distributed over 3 coppers. Each copper must be a +2. And so if each copper must be a +2, that's going to be copper to phosphate. And so name would be copper, Roman numeral 2, parentheses, phosphate. So here we got copper 2 phosphate. Alright, the next is calcium, which is a fixed charge +2, and then iodate is an IO3 minus, therefore IO4 minus would be per iodate, and so that would be called calcium per iodate. I'll just write that out, calcium per iodate, like that, calcium per iodate. Oops, you know what I'm doing. Sorry. I just did the wrong one there. Iron 3 iodide copper. Actually, I was supposed to do manganese. I'm tired. Or, I don't know. Next one is manganese with hydroxide. Manganese is variable charge, so in this case it's got to be a +2 because we have 2 hydroxides. And so it's got to be manganese with the 2 plus, since we've got to balance out the 2 hydroxides with the 2 minus charges like that. And so, since manganese is variable charge, it's going to be manganese with a Roman numeral 2 hydroxide. Now, manganese is a 2,3, and so this would be manganese hydroxide if you're using the old naming system. Okay, next is calcium sulfite. Well, we know sulfate. Sulfate is an SO4 with a 2 minus, so sulfite's an SO3 with a 2 minus. And so this is just works out CaSO3. That'll be it there. Then we have a Cu and a Cl. Cl is a -1, therefore Cu must be a +1, so that's going to be copper with a charge of 1, chloride. Copper is a 1,2, so this would be cuprous chloride. Silver is fixed charged, and then NO3 would be a nitrate. So this is going to be silver nitrate. Nitrate's a -1, silver is +1. Balances all out. Al2Se3. Oops, the answers are there, sorry. Al2, aluminum is fixed charge, so aluminum, and then Se is a 2 minus, it's aluminum selenide with a D. There we go, aluminum selenide. Okay, 82, magnesium. Alright, magnesium is 2 plus, so that's magnesium ion, and then it's the HPO4. HPO4 is actually a 2 minus ion, so balance out. HPO4 2 minus is hydrogen phosphate or monohydrogen phosphate. Okay, then we have potassium, which is K plus, and perchlorate, which is ClO4 minus. And so that just works out to KClO4. Bromous acid. Okay, now with bromous acid, what we're going to do is we're going to change the Aus acid to figure out the ion. It's going to be bromite. Well, bromate is BrO3 minus, Therefore, bromite must be a BrO2 minus. There we go, BrO2 minus. BrO2 minus, how many hydrogens do we need? We just need one hydrogen, so it's going to be HBrO2. This would be bromous acid, HBrO2. Okay, and then finally we have nickel with a carbonate. Carbonate's a 2 minus, CO3 2 minus, therefore that's going to be a nickel with a plus 2 charge. So it's nickel 2 carbonate. Nickel 2 carbonate. Now the lab manual conflicts because it says nickel's a fixed charge on one page, and on another page it says nickel is variable charge. So we'll treat it, it's a variable charge. And the transition elements, the only ones you have to remember that are fixed charge are scandium group, and then the cadmium, zinc, and zinc, cadmium, and silver. Okay, going on here, we have iron 2 oxide. Iron 2 is Fe2 plus, oxide is O2 minus, so FeO works out. Then hydrosulfuric acid. This has the hydro prefix and the ic acid. Whenever we have a hydro ic, then what we have to do is we change the ending to an ide. Oops. And so hydrosulfuric acid must mean we're dealing with a sulfide ion. S2 minus is sulfide. Now if we're dealing with S2 minus, then it's going to be H2S, because we're going to need 2 hydrogens for every sulfur. It's H2S. H2S. Okay, next we have strontium iodate. Now iodate is an IO3 minus. Iodate. IO3 minus. IO3 minus. So strontium iodate would be an SrIO3. I'm going to take that twice. SrIO3. Strontium is a 2 plus. Then we have sodium hypochlorite. Sodium, okay, chlorate is a ClO3 minus. Chlorite must be a ClO2 minus, and hypochlorite must be a ClO minus. And then we have a sodium, so it's NaClO. Yeah, that's the sequence there. So chlorate, chlorite, hypochlorite, and sodium hypochlorite at the bottom there.